Greek letter that makes the sound P. Now, I don't know if any of you have heard about the golden rectangle before?
No, golden ratio, but not golden.
Golden rectangle, well, the golden ratio is related to the golden rectangle.
I don't even know what I do them.
Okay, so the way we talk about a golden rectangle, let me draw this a little better.
Is it like a perfect rectangle?
I'm trying, it's perfect in a certain sense. Let me see if I can make that sense come true. We'll approximate it. The idea of the golden rectangle
I know what a golden rectangle
is if you take the
I
rectangle.
know. I really
Yes?
know. Can I
Yeah?
see it?
Yes? So you have to stay there. Tell me from there.
Because you see that bigger chunk?
Yes, the
And
square.
the smaller chunk? The smaller chunk times 5 equals the bigger chunk.
Well, it's actually even better. Yeah, it's actually even better than that. The idea is that this area here is similar to the entire rectangle. So what does it mean similar? Yeah, Luca?
The same dimensions, but not the same size.
Right. So for example, let me just ask this. Is this rectangle similar to that one? Is this rectangle similar to that one? Maybe. Depends on how well I drew it, right? But the idea is that if you blew that up with a copy machine, it would, so that this edge was the same as that edge, then this edge would also be the same as that edge, right? That's the idea of similar. So that's what we're doing here. We're going to take this rectangle here, blow it up, so that this edge is the same as this edge, and that should be, this edge should then be the same as the other edge. Has anyone worked with similar triangles and proportions at all?
No.
Anyone talk about that? Let's do a little bit of that.
Similar triangle.
Let me do this. Okay, suppose that these are similar triangles. Not sure they look perfectly similar, but pretend. And suppose that this is this one here has a length of 6, and this one here has a length of 3. If this length is 4, what would this length have?
I know.
Do you?
It would be like, since that edge
Wait.
is 3,
Maybe.
Do you know what it is?
Maybe, and like,
Yes.
is it 2? Because
Because why?
because 4 is 2/3 6, so 2 is 2/3 of 3.
Nice.
That's why. I
So you
thought
set up as a proportion in your head. The idea is that the ratio of these needs to be the same. 4 is to 6 as, I'm going to put an x in here, x is to 3, and you're trying to figure out which number here would make those fractions be the same. There's another way to see it too. What would you have to do to the 6 to turn it into a 3?
oh, you would have to divide it into 2.
And so 4 divided by 2 would be 2. So that's another way to see it. Does that make sense?
Yeah.
And this is something you can always do whenever you have similar polygons. If they really are similar and you know some of the edge lengths but not others, you can set up a proportion. So we're going to do that with phi. I want to write this edge length right here is going to be called x for a second. And I'm going to call this one x, and I don't know what this is, so I'm going to call it y over here. So this edge length is x, and this is y. So I want to set up a proportion saying that this little rectangle is proportional to that big rectangle. So somebody tell me how to set that up. Let's start with this one. Who can tell me what the length of the shorter side of that rectangle is? What is it? Can you tell me?
Me?
Yeah, the length of the, okay.
I'm pretty sure that I think half X.
What's that?
I think it's half of X.
There's a chair. Grab one of these or that.
Y? What's Y?
It's y. So the y is the shorter side, right?
Yeah.
Yeah. So y is the shorter side. And what's the longer side of this little rectangle? Everyone call it out?
X.
X. Does everyone see that? It's got to be the same as that, right? That's got to be proportional to, that's got to be equal to the shorter side of the big one. So what's the shorter side of the big rectangle? X over the longer side, which is X plus
Y.
Y. So that's the idea. Now, that's all right, but I'm a little bit, I think I can be more clever than this, though. The problem with this equation is that it has two letters in it, right? That makes it harder than normal. So remember that this rectangle, this golden ratio, is something we should be able to scale up and down as big or as small as we like. So we can pick either the x or the y to be whatever number we like. And I like 1. 1 is a good number. Nice and simple, right?
Yeah.
So would we rather have, I'll let you guys pick, would you rather have x be 1 or y be 1?
Y be
one. So we want to scale this up? Let this be a 1? Okay. So we're going to have this be 1. So that's going to change this to a 1 and this to a 1. So let's see what happens when we work this out. Does anyone know what we can do with proportions to make them simpler?
How can y and x be both 1? That doesn't make sense.
Oh, just y is 1.
Oh.
So we changed it, so now we've got a 1 is the short side of the rectangle, x is the long one.
But how is x
X is
plus
the short one, and the long side of this rectangle is x plus 1.
But x plus 1, how is x plus 1 equal to x? That doesn't make sense.
Well, it's not equal to x.
Then what
The
is
fraction is equal to the fraction.
why?
Oh, that's what it means for two figures to be similar, that you can make the short side, a fraction of the short side over the long side, and compare that to the short side over the long side of the bigger one. And that fraction should be the same.
So you're trying to figure out what part of that rectangle is of the other rectangle, right?
Right. And we're trying to say, if we had a figure like this, where when we chopped off a square, the remaining rectangle was similar to the original one, we're trying to figure out something about x. And that's going to help us find phi. So you guys ready?
Yes.
Let's do it. Does anyone know what we can do algebraically to solve things that look like this? Yeah.
We can cross cancel X and X.
You can't cross cancel because it's not multiplication, right? Canceling, normally you could cancel because division is the inverse of multiplication, right, Asian? If this were a multiplication symbol, I could cross cancel them because this is a division symbol and this is a multiplication symbol. So multiplication and division would cancel out. But it's an equal sign. So they won't cancel. But what will they do?
By the way, since you said x is 1, you can just put
No, y is 1.
what?
Y is 1. We decided y is 1.
Y is
They
y
chose
the
y.
smaller
I would have
rectangle?
chosen X.
Well, we can do it that way too.
But is y the smaller rectangle or the bigger rectangle?
Y is the length from here to here on the smaller rectangle.
And what about x?
X is the length of the side of the square. It's this length and it's also this length.
Actually, I think
Yeah?
it would be easier if we chose X to do it instead to X to be 1 instead of
Oh, do you think so because we would only have it in 2 places instead of 3 places?
It would be easy to figure it out.
So do people want to change their mind for that reason?
Oh, I know a way.
Let's do it.
I know a way.
We're changing our minds. So we're gonna make this one be x, we're gonna let this one be 1, we're gonna let this one be 1. We're gonna go back. Okay, let's do it like this and see what this does. So what's the short length of this rectangle again now? What's the short way of this rectangle?
1.
The short way, x. The long way,
1.
1. Now the big rectangle, what's the short way?
1.
And what's the long way?
X plus 1.
Oh, that does look easier, doesn't it? All right.
I just figured out.
Now, how can we simplify this more? Wait.
No, I know how to find phi really. No, in that way.
Wait. Go ahead.
Well, x divided by 1 would be x.
It sure would. This can simplify down to x. And now we have this. Does anyone know what we can do to simplify an algebra? Do you know how to simplify the algebra?
No, that.
I'm talking about the algebra.
Really, I know another way.
Wait. You save it, write it down in your book, and then we'll come back
No,
to it.
I'm not going to do this, use that. I'm going to use that to do it.
Excellent. Write it down in your book if you might forget. We'll come back. Let's hear about the algebra. How can we get this x plus 1? The problem is it's a fraction, right? How can we get rid of the x plus 1 in the denominator? When you have an algebra problem and there's a nasty fraction.
Then you look up the answer on Google.
Okay, let me ask you that. If I have something like 3 20ths, and I subtract 1 from the numerator and the denominator, is that the same fraction?
No.
Shoot. Okay, that's not gonna work. So what can I do? Aiden, yeah?
You could divide them by something.
I can. I'll give you a hint. We actually want to multiply by the same thing on both sides.
1? No.
Better than that.
X by X.
What would make this all go away?
X.
What would cancel with this whole thing if we multiply by it? Yeah?
If we multiply by x plus 1.
Yes.
Can I?
Now let's see what happens. This now, dividing by this and then multiplying by it is just canceling out, right? It cross cancels like Asian was saying. So now we've got this. X plus 1 times x equals 1. Tell me what I need to do with this, you guys? Do you know what to do with this? No, we're not ready for that yet. We're talking about algebra right now. Yeah?
We put the 2 x's together to become x squared.
You're right. We're sort of distributing this in, right? And so that's going to be x squared. And what's this one going to be? X times 1. What's that? X. And it equals 1. If we could solve this, x squared plus x equals 1, we would be good. And I'm going to do one more thing to it. I'm going to get the 1. I'm going to subtract 1 on both sides. You're next. And this would be equal to 0. So this is what we're looking for. We're trying to figure out what x will solve this. We're going to solve that in a second, but first, let's hear Riza. Riza, what's up?
I think if we go from those sides, what I was thinking is if we add those sides together, those sides.
1 plus 1 plus x?
No, if you add 1 plus 1, you get a line that's 2.
That's true.
And if you divide that line by just 1x, and you find that.
Why would I divide this by x? What would I be finding if I divided that by x?
No,
Does that mean anything? Taking this and this.
No, what I mean is you try to see how many of those x's can go in that line.
Into
and
that
then
line.
you keep if you keep on doing that, you find more and more decimals.
That's true, but the problem is that I don't know what x is.
Oh.
so I can't do the division. But if we can solve this, we will find phi. And we will solve this today, yes.
So I was looking in 1x, I think x equals 1,
Okay.
because, 1x.
X can't equal
Does x equal 1? If you do 1 squared, what's that?
1
1
plus 1.
plus,
plus 1
oh, no,
minus
that's
1.
equals 0. So,
It's 1.
It's not 1. So let's save this. I'm going to write this up here. Actually, by the equation. I'm going to put down x squared plus x minus 1 equals 0. I'm going to erase all this. And we are going to learn how to solve problems like that. So,
I have an idea.
no. We are going to use the quadratic formula. We're going to find the quadratic formula.
Yeah, I've already tried written down.
Yes, but how do you know that? Did you look it up?
Yes?
Well, yeah, where did it come from? This is how it comes, how they figured
Well,
that
I
out.
know how it came from.
How, what?
Because there was a person that discovered this.
Yes, and how did he discover it?
Because there was a person that was thinking about like a bunny family, and he thought like if
Yeah,
you
the bunnies did not help them with this question, though. That was
no,
later.
they have.
But you're right that they're related.
1 plus 1 equals 2,
Uh-huh.
and 2 and 1 plus 2 equals 3.
And how did that turn into 1.618033?
I
How?
know, because if you keep going further
Uh-huh.
and keep going further and dividing,
Yes.
it will get closer and closer to 5.
What does that have to do with this picture?
Uh,
You have to find 5 from this picture first before you can make the connection. But you're right, they're related. But we're going to prove it. We're going to find it.
Fibonacci sequence is related to the golden
The
ratio.
Fibonacci sequence is related to the golden ratio. It's crazy, but true.
we learned it from Africa.
No, I don't think so.
No, because
Fibonacci.
he went to Arabic mathematics.
Sure, Arabic, yes. All right, are you guys ready? Let's do this. First of all, we have to discover the the quadratic formula. Now, the Babylonians already knew the quadratic formula. They didn't write it with algebra. That took
That's in
Arabic
my
mathematics. Yes. We are going to learn that. Here's the idea of the quadratic formula. There's something called completing the square. So let's try this. I want to do x plus, someone give me a number, nice number.
343.
3 is a nice number.
No, 344.
Yeah, but 3 is nicer. So we're going with that.
What-
I
what-
want
what-
to do-
15926 repeating.
Well, look this.
X.
What does this mean?
It means
Means
x
x plus
plus
3
9.
times x plus 3.
It does. It means x plus 3 times x plus 3. And I can draw a picture of
So
that.
x squared plus 9.
I can draw a picture of x plus 3. Here's x. Here's 3. Here's x. Here's 3. What's the area of this piece?
X squared.
X times x squared. What's the area of this piece?
3 squared. 9.
9. What's the area of this part?
3x.
3x.
Oh,
What's the area of this part?
3x.
So is x plus 3 quantity squared the same as x squared plus 9?
Oh,
Is it?
you just gave me a really good
Is
idea.
this, and this all of the square?
For now.
So is x plus 3 quantity squared equal to x squared plus 9? Is that true?
I think you gave me a really good idea of
Is
how
this,
to do this.
is this true?
You just gave me a really good idea.
That's not true. Because we will have missed out on the skinny rectangles, right?
I know something that's involved with this, really.
Yeah, what is it?
You see, like x squared. I was like thinking, can I get out of my seat and use the marker, please?
Quick.
Okay.
I don't know if you can get out of your seat, though. You might be locked in there.
What? Yeah.
I don't think you can get out.
You just keep your legs in.
Oh, Shlomo rescued you. Here you go.
Like, do you see this x?
I see
When
that
you
X.
were talking about the Petronelli
Quadratic formula, you mean?
If you like, can I draw some lines
went right over here, you mean?
Like,
Or if you did the whole thing?
no, the whole
And what about
thing.
the rest of it?
The
What about
rest
the
of
3x and the 3x and the
rest,
9?
those would be equal if you, those would be equal to this because the square, because it's like a half, this would
Yeah.
be a half square, and that half square would be this, so the rest of this would be also equal to this square. So I was thinking that if you divide that this is equal to this square here,
I think you should draw that on your
divided by the
paper.
square root of 2.
Draw that picture on your paper and show me what you mean. Yeah,
This is backwards.
yeah.
Was our original thing x the squared time plus 1 minus 1?
Well, this is the equation we're trying to solve. Is that what you're asking?
Yeah.
Yeah.
Oh, okay, that's right.
That's where it is. You're trying to find it, huh?
Yeah.
Good.
Sorry.
Keep going. So, let's do this. So we got x plus 3 and x plus 3. We know that this is equal to, actually, x squared plus 3x plus 3x plus 9. Has anyone talked about the distributive property, double distribution?
Yes.
Or FOIL, like this?
Mm-hmm.
That you can take this times this, that's the x squared, x times 3, that's the 3x, 3 times x, that's 3x, 3 times 3, that's 9. Yeah? And this simplifies. Which ones of these can be combined together? Which terms are like terms? And we'll
3x.
The 3x's.
So it'd be 3x.
So x squared,
Times 2.
what is 3x plus 3x? How many x's is
3x
that all
times
together?
6.
6 x's. Plus 9. There it is. Now, here's the thing. If you're walking down the street and you saw x squared plus 6x plus 9,
Yeah.
how could we tell that that is actually equal to what's called a perfect square? Meaning, something that can be drawn as a square where it has two pieces here that are added up on each side, and those are equal. So let's do another example before we get to, someone give me another number besides 3?
5.
5.
This is x plus 3 times 2. X plus 3.
So if we do out the square, we got x, we got 5, we got x, 5. What are all the pieces here?
X squared. 5x.
5x or x5, same thing.
5x.
5x
And
25. And so this one, x plus 5 squared, is actually x squared plus, these are going to get added up together. What are they going to be? 10x plus 25. So what is the signature? Well, for example, is that one a perfect square? Can someone write down one of these creatures that has something squared plus something x plus something that is a perfect square that we haven't already seen? Yeah, can you give me one?
X squared plus
Give me one that's going to work.
12
12x plus
24.
24?
no, 144.
144?
No, it's 36.
Which one of these should it be?
36.
36.
How can you tell? What pattern are you noticing? Can you say?
Because it's always half of the number of x.
Take half of that and
Yeah.
get 5, right?
And then you square it, and that will be the
Okay, let's check that here. What's half of this?
3.
Oh, yeah.
And you square it, you get 9. So let's see, half of 12x is what?
6.
And square that, you get?
36.
So that is the one you want, isn't it?
Yeah.
Nice. So, let me ask you this. Suppose I start out like this. X squared plus
3. No.
200x. What will the final number be if I want it to be a square? Yeah?
1,000.
Is it 1,000?
Yeah.
That's 100 times.
What is 100 times 100?
1,000.
No, wait, it's 100.
10,000.
Yeah.
10,000.
10,000. There we go. That's it. So that trick of taking half that middle number and squaring it is a way you can make squares.
Wait, what's the trick exactly? I don't get it.
Okay, can someone say it again? Yeah, Ethan.
It's, the,
So when we did this, how did we get this?
we did 200x divided by 2, divided by half, and half, and then we did that square.
So the idea is like this. If I have x squared plus 40x, the concept here is that I have an x squared, here it is, but that 40x came from two strips,
It's
right? So it came from a 20x strip, and it also came from a 20x strip that was down here. When we're completing the square, we're trying to find the little number that goes in the corner. In this case, what we can see is this should have been an x, and this should have been a what?
Yeah.
What should this be?
20.
20.
So it's 400.
So it's 400 that goes in that corner. Does that make sense?
Yes.
Alright. So completing the square is the process of finding the little corner if you're given the other parts.
And what does that have to do with the golden nation? Like, why would it?
Well, to solve that, we need to complete the square. So we're going to do that.
I still don't get the formula for the first square.
What they're saying is that you can take half of this and get 20 and then square it.
And that's the golden ratio?
No, that's the number that you need to complete a square.
Like, that's how much the whole area of the rectangle is?
That's the area of, well, all we're doing when we fill it, well, right now all we're doing is trying to fill in a square. We'll talk about the, we'll talk about this in a second.
But 10,000 isn't the area of 20 times 20.
Oh, that is so true. This was the problem down here. So what should this be, you guys? What should I fill in here? 400. You're right, that picture doesn't match, does it?
But can't you just do 20 times 20?
Yeah.
Or do you have to do the whole?
Well, it started out as 40x. So we had to take half of it and then square it to get that little piece. Does that make sense? Okay. So now let's get at the b a little bit. So we've got x squared plus x minus 1. The reason that this is, one reason that this is hard to solve is that there are x's over here and there are x's over here, right? Well, let me ask you this. X squared equals 49. Can anyone give me solutions for x?
Hold on. 7.
And?
What?
And, or x could also be?
Uh,
Yeah,
-7.
yeah. Is that what you were going to say? Hayden?
Yes.
-7? We can write that like this. X equals plus or minus 7. We're going to try to write it really compact. There are two answers. A -1 and a +1, right? Because a negative times a negative is, so we get two answers there. This problem isn't so bad to solve because it doesn't have an x squared and an x, right? It's just got one kind of x, x squared. Yeah?
If there was 1x, and we ended up with two answers, if they were both corrected, we would if we had 1x squared, and that it got us two answers, if we had an x squared and an x, would that get us three answers?
That's a really good question. How many answers should we expect if we have an x squared and an x? Do we know what the picture of this looks like? The graph? That's something you could do. You can graph this picture by putting in different numbers for x and see what comes out for y. Does anyone know? Well, let's actually do this.
It's a table.
Yeah, let's make a table. Yeah.
When you do this, what do you get out of it? What does this help you with?
When we get this, we will find the b.
No, like this, like what you showed us had divided by 2 and then squared. How does that help you?
it helps us because if we can write something as a perfect square, we can solve it. Let's do this one really quick. Let's save this for a second and come back to this question. Can anyone tell me how to solve this equation? What should I do first?
Find out what 3 times what equals 48.
Yeah, 3 times what equals 48?
So 48 divided by 3.
Basically, we're dividing by 3 to figure out what that is. What is that?
16.
So can anyone give me an answer to this?
16.
16, that's 4.
Plus or minus
Yeah.
4. Let's try this. What if I give you this? This is a little harder. See if you can find answers with this.
Oh, I know one.
Everyone try, work on paper or work
Oh,
on
I
phones.
know. I know.
Try to find both.
I know the answer
Oh, I know.
already.
2 answers?
I know.
Yes.
Write them on your paper.
Because
Write them on your paper.
oh,
Write on your paper. You should be finding 2 answers.
I have it.
You write them on your paper if you got it.
I don't know. Right. I have it.
Can anyone give us a hint about what they thought about first?
I thought
X minus
what 3 squared equals 49.
What squared equals 49, right?
7.
Right.
Plus or minus 7.
Plus or
And
minus
then
7.
just
So
subtract
x plus 3
and
is
you'll get
equal
x.
to either plus or minus 7, right?
So just subtract 3.
And then subtract 3. What answers did y'all get if you subtract 3?
4 or negative 2.
So x is either equal to, I mean, I guess I'm gonna write this separately. Either x plus 3 is 7, or x plus 3 is negative 7, right?
Yeah.
So what would it have to be here for this to be true? What x will work?
Positive 4 or negative 10.
Or x equals negative 10. That make sense?
Yep.
So if we have a perfect square, Teresa, if we have a perfect square, and it's all packaged up nicely, it means that we can solve it.
Yeah, but we
But when we
already
have it
know
in 2
the
pieces, we
square.
can't.
We already know the area of the square because we wrote 1 by 1.
Well, this square is not that square.
So why do you even need that square?
Ah, we are going to complete the square. This isn't a square, it's rectangle, right? This was rectangle. We're gonna solve this by making a square. Yeah,
I think that equation can be better written as x squared plus 1x plus negative 1 equals 0.
let's try it. X squared
Plus
plus
1x
1x,
plus negative 1.
right? Or better yet, maybe I'll just stick this negative 1 back on the other side, right? Equals 1.
I have a question. What if you do this with that square? What if, can I show you something really fast, please?
The magic word.
Go ahead.
Like, I was wondering, if you, make, you see here, square. Put that, no, it's not a square, it's like a rectangular, and you put it in here, and the height is the height goes there.
Well, how do you, is this 2 squares or is this a square and a rectangle?
I'm just doing this. If you put this in here,
Yeah.
and you see,
But is this the same as this?
no, I have to make it a little more perfect.
Right, well, my rectangle isn't very golden, I guess. But, okay, so you've got a square here and a square here. What's your question?
So, if you put the square, if you put this rectangle in there,
Yeah.
here,
Well,
And,
it'll be a bunch, so slice that up.
and you let me see that, it might this square could like be maybe half of the half square in that square.
Maybe so, except that we don't actually have an x squared in this picture. We would have to build that separately. I see what you're saying though. The x squared would be this, wouldn't it? So that would be x squared?
No, what I'm saying is like this, like if you do a half line and you put it here,
Well, it wouldn't be
that-
half, it would be x to make x squared.
And if you like, then maybe that one would be like that half square inside this square, and this square might be part, like a, fractional part that you could put.
It's not gonna be a nice fraction, that's for sure. All right, it's gonna be irrational, so it's not gonna work out as a fraction. All right, so let's try this. Aiden asked, how do we know how many solutions this might have? And to answer that question, let's put in some values here. What happens if you put in -4, you guys, into this? I'm just going to draw it like this. Y equals x squared plus x minus 1. So if we have that equation, what do we get for y if we plug in -4? So what is -4 squared?
16.
Positive 16. 16 plus a -4 is? What's 16 and -4?
16 plus -4 is 12.
12. And 12 minus 1 is?
11.
Okay. Let's do -3. What do we get? So -3 squared, everybody?
9.
9 minus 3 is? 6 minus 1 is? 5. Let's
Could
look at
also be
-2.
-3. Oh, no.
4. 4. Plus a -2.
2.
Minus 1.
1.
-1. What do we put it? What's going to happen here?
1.
1. Plus
1.
1. Or 1 plus -1, right?
So 0.
0.
Minus 1 is -1.
So somewhere in here it crosses 0, right?
So let's
So there's a solution in here.
Let's
Well, let's
try
keep going.
negative
What about
1.5.
0? We will, but let's go for 0 though.
0.
0 squared is 0, plus 0 is?
There's someone
0
on the
minus
side
1 is?
and someone on the
-1.
side.
You can come in. Cheryl, you can come in. Okay, -1. Now, something weird is happening here. It stayed the same. So let's look in between these two numbers. 0 turned into -1. What about -1/2?
I'll use
That's
the
a little harder.
calculator for this.
-1/2 squared. So what is -1/2 times -1/2? How do we multiply that?
Oh, I know.
What's half of a half? 1/4?
So,
Positive 1/4. We also have to do minus, or plus a -1/2. How do we do that? How do we do 1/4 plus a -1/2? Yeah, this can be changed to have a common denominator, right? What will it be?
-0.25.
Yeah, you can think of, it's just gonna be, it's like having a quarter and spending 50 cents, right?
Mhm.
It's gonna be -1/4. Sure enough. And then -1. What's -1/4 minus 1?
-1.25.
Yep, -1 1/4. So, it even goes down a little lower. And then what happens at 1?
1.
1 plus 1 is?
2.
Minus 1 is?
1.
And what happens at 2?
4.
4 plus 2
1.
minus 1 is?
It gets 1.
5. And what about 3?
I'm guessing it's 11, maybe?
Oh,
Just
look, is there a
hunch.
pattern
Just
here?
a hunch.
Let's check it. 9 plus 3 is?
12.
Minus 1 is? Sure enough. Here's the point. If we plot these points, if we go over -4, up 11,
Oh.
-3, up 5, -2, up 1, -1,
Okay.
down 1,
That's quite the parabola.
It is quite a parabola. 0, actually in between here it goes a little lower, doesn't it?
What if,
And then,
Wait, what's a parabola?
good question.
I don't know.
And then 2, up 5, and then 3, up 11. If we connect these dots,
Makes.
it,
Oh, my dad showed me
If
this,
I-
I think.
cheat a little bit, draw this properly. That is a parabola. This kind of, it's sort of U-shaped.
Wouldn't there
that's
be 2 points where it comes to 0?
There will be 2 places where this crosses 0. So Aiden, we should
2,
expect
5.
2 x's from this
I
answer.
have a question.
Even though it has an x squared and an x, it still only
One
gives
is
us 2
negative, the other
answers.
is positive.
In this case, yes. Mhm.
What
That
if,
means there would be.
what if like, can I use the microphone?
No.
What if like, you see that half screen I did?
Yeah.
I'm not gonna do the same thing, but the other link that doesn't like fit in with that.
Draw it on your
square-
paper and so that you can see what you're talking about. Okay? So here we've got a parabola and something that's true is that everything that has the highest power x squared, something x squared plus something x plus something, it'll always look like a parabola. It might be like this, going upside down,
Yeah, it might be a
or it
negative
might be
parabola.
right side up, but it'll be something like that. And sometimes there might be 2 answers, 2 places where it crosses 0. 2 places where if that was set equal to 0, you would have an exact value. But there's other things that could happen. What else could happen with this? If you just have a U and a line, what else could happen with it?
Could
Can I
have
say
zero
something?
answers.
It could. How would that? How might that look?
For it.
It would look like this.
Like this, or like that. It could be a parabola that doesn't cross that line, right?
Yeah.
So it might have no answers. What is another possibility? It could have 0 answers. It could have 2 answers.
It could
They
have
go on
more
the
than
line?
2 answers.
Could it have more than 2 answers?
Well, if it stays at 0, but
If it's a U and a line, can it have more than 2 answers?
no.
Could have one answer.
How could it have one answer?
If it just
If
touched
it
the
doesn't
line.
touch
one
the
is
line.
Just like that, right? How about somebody who's trying to get in?
I can go up.
Here, I'll go do that.
Hello? Yeah, hold on a second. Can I get you to take
Somebody who's trying to.
I'm not sure. Hello?
Can I say something?
All right.
Yeah. So, like, what I wanted to say is, you see that square?
Yeah.
I was wondering, the side that doesn't.
Did you draw that on your paper? Yeah? Okay, I see
The
it.
side that doesn't match the pink square might match one of this a side of the half square, which I've drawn right here, because on my paper it's exactly the same. See?
Yeah, but how do you know that you didn't make a mistake and that in real life it isn't exactly the same?
Ooh, good
It's close,
question.
probably.
I don't know. Better be more precise. Okay, let's check this though. Let's actually solve this using the completing the square technique. So we talked about moving that back over there to positive 1. What was the trick again? If you have an x squared and you have something here with the 1, you told me to write the 1,
Yeah, I don't know.
Shalom did.
So
What
that
do
would
I
be
do to figure this out?
So a half square
Divided by
divided
Divided by
is
2.
square.
What's 1 divided by 2?
0.5.
A half.
Half.
And then what do we get when we square that?
1.
Uh,
Fourth.
A fourth. Half of a half is a
Of
fourth.
course.
Sure enough.
Wait, so what's.
But here's the problem. I want to put a plus a fourth right here, but if I've got 2 things that are in balance, algebra comes from Arabic words meaning to keep in balance. So if I want to add a fourth here, I have to be fair to the other balance pan, right?
Yeah.
I need to add a fourth on this side too.
Yeah.
What this tells us is we should be able to write this side now as x plus something. What's the something?
1/4. No. 1/1.
Whatever it is, x plus that something and x plus that something are going to be the same as this. Let's look at this one again. What did this one turn into? X plus 40x plus 400? What did that become?
X plus
What was the size of the square?
20 squared. So it'd be x plus
It'd be
one
x
So
fourth.
if we draw that square on
X
here,
plus a half.
we have an x something, we're not sure what, and an x and a something, but we know this is a
Is it
fourth
one
down
fourth?
here, so what does
One
this have
half
to be?
times
One
x.
fourth?
A half. Because a half times a half will be a 1/4. Let's check this out. What's x times a half?
X.
X times a half.
1/2 x. What's a half times this x?
One half x.
And what's a half x plus another half x?
One fourth.
1/2
One.
plus a half?
1x.
1x. Half of an x plus half of an x is a whole x. Yeah? So this will work. If we put in what number right here?
A half.
And square. So then this side is just going to be 1 1/4. I want to write that as an improper fraction though. How do I do that? Yeah,
You
five
do
fourths.
1 times 4.
plus the 1, 5/4. Okay. Now what? Is this a nice number to want to find, well, something that's it's squared makes 5/4? Is that a nice number
Yeah.
to be the result of a square?
Well,
It
let's
isn't.
see.
It isn't. But what we can do is, what's the opposite of squaring? So if I have x squared equals 25, what can I do to both sides?
Ooh, can you find
Yeah.
square root?
Square root. Square root.
Square root?
You can always have to put the plus or minus. So we can take the square root of both sides. Square rooting is the opposite of squaring.
Yep.
So we can do that. We will square root, I'm going to write it as a separate step. We can square root on this side.
Wait, so what are we using this to find?
We are going to find b.
Wait, how do you square root on these calculators?
You
Oh, I
don't.
know how to.
Just leave it alone. Don't do it on the calculator.
I know the way to square root by yourself without the calculator.
Yep, that's okay.
Magical.
We're not going to do it right now though.
I did.
So right now, we're going to do plus or minus. Now, the square root of 5 over 4 is the same as the square root of 5 over, what's the square root of 4?
2.
2. Finally, what do I have to do to get the x alone over here? What's the opposite of adding a half?
Subtraction.
Subtracting a half. So we're going to end up with plus a half minus a half. It's going to be the same thing as negative a half plus or minus the square root of 5 over 2.
Square root of 5 is not
Sure.
here to me.
Yeah, it's not a nice number, but it's irrational and it's happy. It's sitting there. This is gone. X equals this. Negative 1/2. How are we going to do that? Plus or minus the square root of 5 over 2. Now I have a question for you. What was x again?
X.
No, what was x? What did it stand for?
X
Got it
is
down.
the size of the short edge of the rectangle.
What kind of number is x?
Irrational.
Yes, but what else? Is it negative 2?
No.
No,
Why not?
because you can't have -2.
Negative length. It's not a negative length. So it's not. So looking at this answer, you guys see this negative a
It
half
needs to
right
be
here?
plus. It needs to be plus.
Can it be negative a half minus the square root of 5 over 2? Is that going to be the answer?
Nope.
Nope.
So that first dip in the parabola is not me.
That's not it. We don't want that one in the parabola. We want this one. Now, go ahead and work your calculators.
I know something.
Well,
Wait, but how would we do the square root on
I would start with the square root of 5 on your calculator
the
first,
square root of 5.
then divide
is-
by 2, and then subtract a half. Or
What the
the
square root of
What
5
do
is.
we do?
Yeah, but your calculator can give you an
What
approximation.
do we do?
Yeah, and it'll give me.
Wait, how do you find the approximation on
Use your
these?
calculator, find the square root of 5, divided by 2, and then minus a half. Where is the square root button on there?
I don't know.
Oh,
That's why.
good question.
the
Can I see?
question.
5.
It's shift.
It's the shift and then this
And
X squared
then
button. See how it's written in
minus
orange
a
up at the
half
top?
or plus a half?
You have to hit the shift button
Minus
and then
a
that.
Okay, so.
You might have to hit the 5 first.
Okay,
And
zero
then
point
that.
61803.
How do I get a fraction bar?
Okay, I found
What's
5, I
square
guess.
here?
The square root key is the shift and then this button. I think you have to hit the 5 first, then hit that. Try it.
How do I get a fraction bar?
You don't, fraction bar is
Yes,
division.
it
Use
was.
0.5. Just use 0.5. Anyways, I found the answer.
Yeah.
And if you do 1 divided by 2, oh, you're trying to do the 5 square root first?
Is it 0.6?
Oh, you hit squared, not square root. You have to hit the
Yeah.
shift key and then
Yeah.
that.
Yeah.
It's
Wait a minute,
0.6180339.
Then divide by
Divided by 2.
Yeah.
So this
And then
is
you can
5.
subtract 0.5.
That's an
When I do
approximation of
divided
5.
by 2,
Cool.
when I
That's a
do
lot of numbers.
divided by 2, do I also do it minus half?
Minus half?
Mm-hmm.
Yeah, after you get that, you have to say minus 0.5 at the end, after you do the square root of 5 divided by 2.
I got the answer.
Okay, what did you get?
0.6180339.
Oh, sorry. 0.6 what?
18033
1, 0, 3,
988.
988
Okay.
7498.
I'm out of room.
I'm out of room too. That's all I displayed.
I'm gonna
Yeah,
round
that's
it.
because I have a big calculator.
Oh,
Okay,
I'm
so we found out that this length here is 0.618034. Let's find this length just for fun.
No.
What is it? It's
We
gonna
found out
be,
that X, that's the wrong, that's not X. You labeled that earlier because you were doing X squared.
that is a really good point. Thank you.
And you forgot to do something.
This is it right here, right?
Can I say something? You forgot that 4 at the end is supposed to be a 3. The 4 at the end.
No, that's just an approximation.
It is a 3, but the next number is a 9, so I rounded it.
No.
But it's just an approximation. So, if we keep going like this, well, what would this full length be?
1.64.
1.618034 would be that full length,
And that is fine.
and that is B.
Besides, that's not a lot of math.
Now,
0.618034.
Reza, you have on your paper.
On my paper?
Wait, sit down. Nope, sit down. Get down. Okay.
Can I say it?
Wait, no. If we take this number, x, and we add 1 to it, we're going to get 1 plus a negative a half. What is 1 plus negative a half?
1 plus negative a half?
Yeah.
One
Negative
half.
1 half.
Just 1 half.
Okay, you have 1 and a negative, so it's like you have $1, you owe me 50 cents.
It's just saying
half
1
of-
minus a half.
1 minus a half. So that's going to be a half. Plus the square root of 5 over 2. And this is the same thing as what Reza wrote on his paper from what he looked up as 1 plus the square root of 5 over 2.
Yeah, that's true.
That is true. And that, so phi is basically the length of this if you've assumed that this edge is 1. So the golden ratio, that's what phi
Can I
is.
say?
It's this way.
It's 1 to 1.6180339.
Yes.
8, so
The
on.
golden ratio?
Is the golden ratio.
I thought it was the golden square.
It's approximately this. It's the golden rectangle, and the golden ratio comes from the golden rectangle. Wait, and this, if I were to be more precise about it, phi would be equal to this. 1 plus the square root of 5 over 2. That's a more precise way of naming that number. Yeah.
So, actually, what he wrote on what his calculator got is correct because on my paper it said that this number, so it's actually correct.
Yeah, it's correct.
Ratio.
Oh, this is
Right.
According to correct. That's
Solar
solar
powered.
powered. This is solar powered.
Well, that's the approximation of it. Let's just say a couple more words about where we're headed. Next week we're going to talk about what it takes to make a mathematical system
Uh-oh.
so that we can invent our own mathematical
dear.
systems. But we are going to talk about that next week, and it will be helpful to us to have talked a little bit about these kind of algebraic properties beforehand. Yes?
What exactly is a mathematical system?
Like,
That is what, well, we're going to talk about something called a mathematical field. A field of which is basically a number system.
I have a feeling I should feel apprehensive.
Now,
Like we're going to invent our
That's
own.
only giving me a more
It's just
apprehensive feeling.
we're going to invent our own systems of numbers, but we're going to start by looking at the real
Not
numbers.
the ones, but
Uh-huh,
Oh my gosh,
not the ones
crash
with
my
the
typing.
fingers or the eyes or the hallucinatory.
exactly.
But like what I was going more.
I don't know. First, we're going to learn about the regular numbers, the real numbers, and how the number system gets defined for them. And once you know that, then you can decide how you want to define your own field of numbers, your own system of numbers. But you have to know how one works with the rules before you can do that.
I have a question.
Yeah.
Like another way how you could find 5, can't you like do 1 + 1 and keep on going and you'll get closer as you divide if you keep on going on forever?
yeah, you never explained how the Fibonacci sequence is really do.
That's true. We'll have to come back to that. So we'll talk about Fibonacci another time. Actually, you can check this for yourself if you already know the Fibonacci numbers, and you write down a whole long list of them, and then you divide the bigger one divided by the smaller one. You take is everyone, actually, someone tell me Fibonacci numbers. How do they start again? 1, 1. Then what's the next number?
2, 5,
2, because 1 + 1 is
3,
2.
5, 8,
3, 1 + 2 is 3. 2 + 3 is
5, 8.
3 + 5
I
is
made a program that
8,
lists them all
13,
as far as you
blah,
want.
blah, blah. Let's keep going. 8 + 13 is
21,
21. 21 + 13 is
34,
34. 34 + 21 is 55.
89.
He's been calculating them a lot, so he kind of knows them by memory.
These two are my answers.
That's true.
Cool, man.
All right, so let's try this.
144.
Right now on your calculator, take 89 divided by 55.
Okay, cool. 89.
89.
And tell me what you get.
1.618181818.
181818. Now, let's go a little bit farther back. 55 divided by 34.
Mine goes with
What's-
1.97777.
Is this one 1.9?
1.61764.
Because this one-
64059.
I'm so sorry.
I actually wasn't stealing the number.
Can someone say that one more time, Asian? What's this one? 55 divided by...
Just, I can't look at the numbers from this.
Oh, 1.61, sorry, what? 7?
Wait, he knows that something.
Oh, he did on the
Let
calculator.
me do it again. I'm not sure if
Let's do one more up. If we did do one up like this, we did 144. What's 144 divided by 89?
What's this? 144 divided by 89. 144 89 goes 1.6179777.
Okay. The point is, do you guys notice that these are starting out kind of similar to that number?
Yeah, 1.6.
If you go out far enough and you make ratios out of this one divided by the previous one, if you go out far enough, it will start getting really close to that.
Yeah. When I get home, I'll use a program to
To check it.
find the Fibonacci